Welcome to the Crazy Hat Chemist. So here today, another video on thermochemistry number 13. So let's get started. Bam! So today we're going to be doing a heating curve calculation number 2. So here's the question. It says, how many joules are required to change 2.36 grams of ice at negative 3.25 degrees Celsius to steam at 120.00 degrees Celsius. So what we're first going to do here is draw ourselves a graph. We need to make a graph. Here is a generic graph. We need to plot the 2 points here. That is the lowest temperature, the highest temperature. And then we're going to connect those two dots and do all the steps in between, however many steps those are. Okay, and so let's plot our 2 points. There's our lowest temperature, and it is a solid state. That is it's water, and it's at negative 3.25 degrees Celsius. It is below the freezing point, melting point. That's why it's on that portion of the graph. The next temperature that we have here is 120 degrees Celsius. That is the highest temperature here. And that is this point on the graph here. It is the gaseous state of water, and that is that high portion over there. Now we're going to do all the points in between. So we're going to do steps 1, 2, 3, 4, and 5. We're going to be doing every single step on this graph as opposed to the other one. Okay, so we're going to do each of these steps individually, and what matters is the constant that is used. So I want to make sure that you look at the previous 2 videos prior to this, and then look at what constants are at each section of the graph. And each section of the graph has a different constant. So here's step number 1. The step number 1, okay, where you have 2.36 grams. We have the molar mass of water. That way enables me to cancel out the grams. And then I have the constant there. That is the 37.8 joules per mole degrees Celsius. That is the molar heat of fusion. We also have the change in temperature. That is the final minus the initial temperature. The final temperature is the freezing point, melting point of water. That's the flat portion of that first step, which is the second step, if you will, step number 2. And that is that 0 degrees minus the negative 3.25. Now we're going to do step number 2. Step number 2 is the first flat section of the graph, and that is the heat of fusion here. And that is 6.01 kilojoules per mole. And from that constant, I've highlighted the constants here for each step in yellow. For each constant, okay, that dictates what we want. And we want to get joules so that we can add all these up. So therefore, on the right-hand side of the 6.01 kilojoules per mole, we're going to convert to joules. That is the conversion between kilojoules and joules. We also need to get rid of the moles. And how do we get rid of the moles? We're going to use the molar mass, just like we did on step number 1. And then the 2.36 grams. We're going to cancel those out. Then what we're going to do now is step number 3 of the graph. Okay, and we're using the molar heat with the water, the liquid water portion, the specific heat capacity of water, if you will. So if you were to take this number, the constant that is, the 75.40 joules per mole degree Celsius, divide by the 18.02 degrees, 18.02 grams, you're going to get 4.184 joules per gram degree Celsius. So hopefully you see that there. And the final temperature is the 100 degrees Celsius, and then the initial temperature is the 0, and you still have the same mass. That is step number 3. Now we're going to do step number 4, okay, and that is the heat of vaporization for water, and that's 40.79 kilojoules per mole. Again, this is just very similar to step number 2, except that the constant is different. Now we're going to do the final step number 5, and that's 36.5 joules per mole degrees Celsius. And we're doing the same thing here that we did on the previous ones. And on the left-hand side, we have the mass divided by the molar mass of water, and then we have the final temperature minus the initial temperature. Again, the final temperature is 120, the initial temperature is 100. Now what we're going to do is do all these calculations. We're going to round to the proper number of significant figures, which is actually 3 significant figures here. Okay, and so we got 16.1. Notice that the 0 degrees Celsius for the melting freezing point for water, it's actually an infinite number of significant figures. It wasn't given in the problem, but it is a definition, so it's 0.00000, just like the boiling point for water is 100.00000. So I'm not counting that in my number of significant figures when I'm doing this problem. Okay, the next calculation for step number 2, I got 787 joules. That's 3 significant figures. Third step, I got 987 joules. The fourth step, I have 5,340 joules. Notice that's rounded to 3 significant figures. That trailing 0 does not count because there's no decimal in that number. The fifth step, I have 95.6 joules. Notice that all these values in the yellow there that I solved for the heat are in joules, and therefore what we're going to do is we're going to add up all these values, and then we're going to round to the least precise measurement. The least precise measurement is with step number 4. Okay, in the ones column, that 0 for 5,340, that 0 in that step number 4 answer does not count. But the number in the tens column, that is the 4, does count. So we're going to have a number in the tens column that does count, and that's going to be very important. Okay, so here's all those numbers rounded, and I got 7,230 joules is my final answer. That has the least precise measurement rounding wise. Okay, hopefully that makes sense for you. Hopefully that's another awesome video. And here's another awesome hat. I love this hat. Got this from another student, Sean Shelton. Thank you very much. I appreciate it for all your travels a very long ways away. Have a fantastic day. Subscribe to my channel. Give me a thumbs up, and I'll see you next time. Bye now.